Algebraic expression. So what we're going to do is we're going to take a verbal phrase and turn it into an algebraic expression. And then we're going to take an algebraic expression and then put it in English, and then construct algebraic expressions for real life problems. So if we're going to translate a verbal phrase, in other words, words, into math and algebraic expression, we're going to pick out some key words and phrases that help us do that. So I have my four operations: addition, subtraction, multiplication, and division, and some common words that mean addition. So when I'm looking at a story problem or a word problem, I have sum plus, greater than, increase by, more than, exceeds, total of. So I see more than a lot, and total, greater than. Sum is the answer to an addition problem, but any of those words mean to add. So here's an example of a verbal phrase: the sum of 5 and x. So if you were asked to put that into an algebraic expression, you know that sum means addition. So you're taking 5 and x and adding them together. You could write it as 5 plus x or x plus 5. 7 more than. More than is that key word there, just like sum was. 7 more than y. So that'd be y plus 7. Subtraction. Difference, minus, less than is a common one, decreased by, subtracted from, reduced by, and the remainder. Less than is an important one. So let's look at both of these though. B is subtracted from 4. Remember, subtraction, the order matters. Up here in addition, I could have had x plus 5 or 7 plus y. It didn't matter, but subtraction does. So B is subtracted from 4. So we have 4 and we want to subtract B from it. So 4 minus b. 3 less than z. 3 less than z. It looks like it'd be 3 minus z, but less than means to switch the order. Okay, so switch the order, so z minus 3, because 3 less than z. So for instance, let's say that z was 10. 3 less than 10. Well, 3 less than 10 would be 7. So I know that I have to switch the order. To make it equal 7, it has to be 10 minus 3. 3 minus 10 would not get you 7. So 3 less than 10 means to flip the order. If you have questions about less than, just please let me know. Multiplication. Product multiplied by twice means times 2. Percent of is an important one that also means to multiply, and then times, of course. So 2 times x would be 2x. Division, I have quotient divided by ratio and per. The ratio of x and 8 means x divided by 8. Now let's take some verbal phrases and turn them into math. And let's take some math phrases and turn them into words. So if I have 7 more than 3 times x, how would I write that in math? 7 more than's a key word for addition. 3 times x, that means multiplication. So I have 7 more than 3 times, well, I guess I should change my times to a dot, x. Well, just by picking out the numbers and the variables and finding my key words, I already have my expression. I can write this as 7 plus 3 times x. I could write it as 3x and 7 more than that. Either one of those would work. Down here, let's change it into words. So how would you say this? Well, when I see this, I say 6n minus 4. But what's going on between the 6 and the n? They're being multiplied. So if I want a term for multiplication, I could go back a page. Under multiplication, I could use product, multiplied by, times. So I could say a bunch of different things. 6 times n. And then if I say minus 4, we have to be careful here. This wouldn't work, so don't write this down. 6 times n minus 4. When I read that, I think 6 times n minus 4. That could mean that we do n minus 4 first. Well, that wouldn't be the phrase or the expression that I want. So I need to be careful whenever I'm dealing with subtraction. 6 times n minus 4, that could mean different things when people hear it. So I'm actually going to do something different. I could do 4 subtracted from 6 times n. I could do the product of 6 and n, then take away 4. I could do the difference of 6 times n and 4. There's a bunch of different things, so let's try this. 4 less than the product of 6 and n. So 4 less than, okay, that's the 4 minus the product of 6 and n. So I'm multiplying 6 and n, I'm taking 4 less than it. That one works. The quotient of x and 3 decreased by 6. So I need to put that in math. Quotient is a key word, and decreased is a key word. Quotient means divide, decreased means subtract. The quotient of x and 3 decreased by 6. I need to put that in math terms. So I'm dividing x and 3. I'm decreasing it by 6. The subtraction has to come last. 4 times the sum of y and 9. This one is tricky. So I see 4. Times means multiply. Sum means add. And I have y and I have 9. So are we taking 4 times y plus 9? 4 times the sum of y and 9. That looks like it would be right. But according to order of operations, you would have to do the multiplication before you did the addition. So that's not really what this is saying. It's saying take 4 times whatever you get when you sum y and 9 first. So I need to write this in a way that shows I'm taking y plus 9 first and then 4 times it. So I need to add parentheses in there. The next one, I need to come up with a word phrase. So there's a couple different ways I could do this. One way that would work would be the difference of a and 7, and I could say all divided by 9. So I'm subtracting a and 7 and I'm dividing it all by 9. You could also do the quotient of a minus 9, or sorry, the quotient of a minus 7 and 9. The quotient of a minus 7 and 9. And the last one, go ahead and pause the video and select which one you think represents 7 less than twice the sum of a number and 5. Okay, so we should see 7 less than, twice means times 2, sum means add, a number that we don't know is x, and 5. Okay, 7 less than. If I see less than, I know that that's subtracting on the back. Okay, just like in this slide, the less than meant 3 less than z means the subtraction had to come in the back. 7 less than, twice the sum of a number and 5. So I'm taking something times 2. And what I'm taking times 2 is the sum or the addition of x and 5. Okay, so I'm adding x and 5 and I want to take it times 2. But I'm not just taking the x times the 2. I'm taking this entire sum and I'm doubling it. twice the sum, twice whatever my sum is here, I'm taking it times 2. So this would be the correct answer. When you're translating verbal phrases and they involve percents, be sure you write the percent in decimal form. We can't type a percent into a calculator, but we can type a decimal. So let's review what 4% looks like in decimal form. Remember, we always move the decimal over to place values. So when I do that, I get 0.04. Same thing here, I'd get 0.62. And 140% is 1.4 as a decimal. So when you find a percent of a number, you want to multiply by its decimal. So for example, what I'm talking about here is when you find the percent of a number. So say you want 25% of 78. I'm trying to find the percent of a number. You multiply by its decimal. So 0.25 as a percent is, or 25% as a decimal is 0.25. I'm going to multiply that number by the decimal. So the number was 78. I'm taking 78 times the decimal version of the percent. Final answer here would be 19.5. Next, we're going to be constructing a mathematical model. And what mathematical model is just an algebraic expression. An algebraic expression are like things in this column here. They have a variable, a number, and an operation. In order to do that, I outlined a couple steps that might help you, or what the book does. The book constructs a verbal model. So in English, in words, represent the problem or the situation. And then we're going to assign labels to all quantities in that verbal model. So labels could be numbers, it could be letters. And then finally, our algebraic expression will pop up. So let's start with this guy. A cash register contains X amount of quarters. We don't know how many quarters. It could be 10, it could be 20, 100. Plug in any number in a cash register, however many quarters it holds. So we don't know. Let's just represent it with X. And we want to write an algebraic expression for this amount of money in dollars. So let's just say we had a bag full of quarters in our cash register. How would I figure out how much money that is? Well, if I'm going to put this in a verbal model, and in my own head, I'm thinking, okay, well, if I take the number of coins, whatever that is, the number of coins in that bag, so I count all the coins, and I take that number and I multiply it by how much a coin's worth, or a quarter is worth, so the value of the coin, I'd get my answer, wouldn't I? So like, let's say I had 10 quarters in my hand. So I know the number of coins, 10, and I take it times the value of quarters, so 25 cents. 10 times 25 would tell me the amount of money I have in my hand. Okay, so that's the verbal model. You may or may not like writing out these steps. That's fine. I'm not asking you to do that on WebAssign. But what we need to get down to is the expression. Okay, so I'm just going to go step by step. If it helps you, it helps you. If it doesn't, it doesn't. If you can just jump straight to the expression, that's fine with me too. So now let's put in labels. So the number of coins. The number of coins, it says that, I don't know, it's X amount. Okay, so the label there is X. And the label for the value of a coin, well, it depends on what coin. And here we're talking about quarters. So the value of a quarter in dollars. So a quarter in dollars is $0.25. Okay, so I've created a label. Number of coins label is X. Value of a coin, in this case, is 0.25. So my last step is to write this as an expression. So we can write X times 0.25 as 0.25X. I take the amount of quarters in the cash register times 0.25, and I have that amount in dollars. So this would be my final answer. Similar problem here. A cash register, though, now has N amount of nickels, so there's some nickels in there, and D amount of dimes. So we don't know, it's just a handful of nickels, a handful of dimes. How would we figure out the amount of money that is in cents? Well, same type of deal. We want to take the number of nickels, if we know all the nickels, and take that value times the value of a nickel, how much a nickel is worth, right? So if I had nickels in my hand, I'd take the number of nickels times how much of a nickel is worth. Okay, so that would figure out how much money the nickels are. But then we also have to figure out how much money the dimes are. So we take number of dimes and we'd multiply it by the value of a dime. Right? A handful of dimes in your hand, count the number of dimes, take it times 10 cents. Okay, so I have the value of the dimes, and I have the value of the nickels. What do I do with them to figure out how much money it is? Well, I need to add the nickels value plus the dimes value. So that's my verbal model. Now let's decide some labels. The number of nickels, I don't know. We're calling that N. The number of, I did that in green. The value of a nickel, and remember we're in cents. Okay, so a value of a nickel in cents is not 0.05. That would be in dollars. In cents, it's just 5. Right, 5 cents. Then I have number of dimes. I don't know, that'd be D. And the value of a dime in cents is 10 cents. So if I'm going to write this in an algebraic expression, I pretty much already have. But let's simplify this to 5n plus 10d. That means the same thing, 5 times n and 10 times d. This would tell you how much money you had if you had a handful of nickels and a handful of dimes. And the last one, write the expression for the perimeter and area of the rectangle. So here is the area formula and the perimeter formula. Area equals length times width. Perimeter, you can either add up all the sides, side plus side plus side plus side, or you could follow this equation up here, which perimeter equals 2 times length plus 2 times width. Either one would work. So it wants us to write expressions for both perimeter and area. So let's start with perimeter. You can either add up all the sides, or you can do 2 times length plus 2 times width. I'll probably add up all the sides. If this side is 2w, then I know that this side is 2w. And this guy down here is w plus 12, so this guy will be w plus 12. If I'm going to add up all the sides, let's just start over here. I'll take 2w plus w plus 12 plus 2w plus the top side, which is w plus 12 again. And now I want to look for like terms. Of course, I can take all my 12s and combine them. And then I could take my w terms and combine them and add the coefficients. So we're going to add up the rectangles first. I have 2 plus an imaginary 1, that's 3, plus 2 more, that's 5, plus another one, that's 6 w's. And I have a positive 12 and a positive 12, that makes 24. So this is as far as I can simplify. My final answer for perimeter. The expression is 6w plus 24. Now let's find area. Area equals length times width, so I'm going to take the length and multiply it times the width. So 2w times w plus 12. This shows multiplication when it's in parentheses. You can put both in parentheses. You could put one in parentheses. But w plus 12 needs to be in parentheses since it started in parentheses. So I'm multiplying them, and we need to use the distribution property and distribute 2w to both terms in the parentheses. So 2w times a w, so that'd be 2 times 1, and a w times a w, which makes w squared. Drop down my addition sign, and I have 2w times 12. 2 times 12 makes 24, and w times, there's no other w here, so it's just w to the first power, so we're going to write 24w. These are not like terms. I can't combine them to make 26w cubed or whatever you think that might be, because while yes, they have the same variable, they don't have the same exponent. They aren't raised to the same power. So my final answer for area would be 2w squared plus 24w. If you have questions about this notes, please let me know. I would be happy to help.